Welcome to the deep dive. Today, we're really zeroing in on something pretty fundamental if you deal with heating, ventilation, air conditioning, HVAC, building codes, and regulations.
Yeah, absolutely fundamental.
Whether you're, a contractor out there on the tools, maybe
Mhm.
a homeowner thinking about an upgrade, or frankly, just trying to get your head around all this stuff, understanding these rules is key.
Especially with things changing right now.
Exactly. And that's what we want to focus on, not just what the codes are, but why they exist, and crucially, what's new, what's actually shifting as we speak, in 2024.
Right. We've looked at the main sources industry standards like the IMC, IRC, SHRI, IECC, NFPA, and also regulatory stuff like the AIM Act.
So our mission really for this deep dive is simple. Cut through that complexity, give you a clear picture of these evolving requirements. The goal is you stay informed, you avoid those potential headaches down the line.
Couldn't have said it better. Think of it as like your guide to the forces really shaping how we heat and cool buildings now. These aren't just bureaucratic hoops. They actually reflect, what we're learning about safety, about efficiency, and environmental responsibility too.
Okay, so let's start foundational. Part one, why? Why do we even have these HVAC codes and standards? What's the basic need here?
Well, at their core, they serve, I'd say, several really critical purposes. First and foremost, it's about keeping people safe in buildings, occupant safety and well-being.
Right, life safety.
Exactly. They set minimum standards for ventilation, making sure the indoor air is healthy. They deal with fire safety and ductwork. They dictate how things should be installed properly to stop, potential hazards, carbon monoxide leaks, electrical problems, that sort of thing.
Makes sense. And number two,
A huge driver now is energy efficiency. I mean, modern codes are really designed to cut down energy use in buildings quite significantly
how do they do that?
by mandating efficient HVAC system design and also setting performance levels for the equipment itself.
Which naturally ties into the third point, I guess, the environmental side of things.
Precisely. Minimizing the environmental impact is, well, increasingly important. You see this really clearly in rules like the refrigerant phase down, getting rid of those high global warming potential gases.
We'll definitely dig into that more later.
Yeah. And finally, codes create a certain level of, let's say, uniformity, predictability for construction across the country.
Standardization.
Standardization, exactly. It helps contractors work in different areas, helps regulators ensure consistent quality and safety standards.
So just to be crystal clear, these aren't just guidelines or suggestions we're talking about. These have real legal weight.
Oh, absolutely. Building codes are legally enforceable. They're adopted, they're administered by your local and state building departments if you don't comply.
Yeah, what happens?
Well, you're looking at failed inspections, which means project delays. You could face financial penalties, even legal liabilities if a system is found to be unsafe or just doesn't meet the standard. The whole point is making sure systems work properly and safely.
Okay, that really hammers home why this matters. So who are the big players then? Who actually writes these standards we all have to follow?
There are several key organizations. You've got the International Mechanical Code, the IMC. That's sort of the comprehensive rule book for mechanical systems, including HVAC.
Okay.
Then there's the International Residential Code, the IRC. That one focuses specifically on houses, one and two family dwellings,
Wow.
heating, cooling, ventilation for homes.
And ARAE, that name pops up constantly in HVAC.
It does. ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, they develop standards. Their standard 62.1, that's all about ventilation rates for good indoor air quality, mainly in commercial buildings.
Huh?
And HSRA 90.1 is focused on energy efficiency minimums for most buildings, but it generally excludes low-rise residential.
Got it. Any others we need to know?
Yeah, the International Energy Conservation Code, the IECC, that sets minimum energy efficiency standards for both homes and commercial buildings. And don't forget NFPA, 90A, and 90B.
NFPA, that's fire safety, right?
Exactly. Those standards deal specifically with air conditioning and ventilation systems to stop fire and smoke from spreading through the building via the ducts.
Wow, okay. It's quite an ecosystem of rules. So that's the foundation. Let's move into part two. What's actually changing? What's new on the landscape right now? I know efficiency ratings had a big shakeup recently.
Yes, that's a major one. Effective January 1st, 2023. So very much the reality now. In 2024, the Department of Energy rolled out new testing procedures. This gave us SEER 2, EEER 2, and HSPF 2 ratings.
The D2, what does that signify?
It means the tests are done under more realistic conditions that better mimic how equipment actually runs in the field. specifically factoring in external static pressure from the ductwork.
Ah, okay, so it's not just the unit in the lab, it's how it performs connected to ducts. How does that change the numbers someone might see on a new AC unit?
Well, generally, the SEER2 number, seasonal energy efficiency ratio 2, will look a bit lower than the old SEER rating for similar equipment. That's because the test is tougher, more real world.
And there are new minimums.
Yes. The minimum SEER2 required for central air conditioners depends on where you are in the U.S. Down south, it's 14.3 CRR2.
Get up north.
In the northern states, it's 13.4 CR2. And this is critical. These are federal compliance rules for manufacturing and selling new units.
Meaning?
Meaning, depending on your region and when the unit was made, installing an older unit with a lower SEER rating might actually be illegal now. You can't just install leftover stock everywhere.
That is a really key takeaway. Trying to install an older, less efficient unit isn't just bad practice, it could be against the law. Okay, let's shift gears to refrigerants. Huge topic, lots of talk about phasing things out.
Absolutely massive. The AIM Act, the American Innovation and Manufacturing Act from 2020, set this in motion. It mandates a really significant cutback, 85% in the production and use of hydrofluorocarbons, HFCs.
Like R410A, the common one.
Exactly like R410A, which is everywhere. The phase down is happening over the next 15 years because these HFCs have a high global warming potential, or GWP.
So R410A is on its way out. What's coming in to replace it?
We're seeing the industry pivot towards alternatives with lower GWP. Refrigerants like R32, R454B are becoming prominent.
And what's the catch?
The main thing to know is that many of these next-gen refrigerants fall into the E2L safety classification.
E2L, meaning?
Meaning they are mildly flammable. Not like propane, but they can ignite under certain conditions. This is a big change from A1 refrigerants like R410A, which are non-flammable.
Mildly flammable. Okay, that definitely sounds like something the codes need to address for safety. How are they adapting?
They are adapting. Building codes are being updated pretty rapidly to include specific safety measures for A2L refrigerants. This means things like potentially stricter ventilation requirements in mechanical rooms, maybe requirements for leak detection systems in certain situations to warn occupants or shut down equipment. And a huge piece is training.
For the technicians.
Absolutely. Technicians, installers, even inspectors need specific training on how to handle A2L refrigerants safely. There are different procedures for piping, for leak checking, for recovery, for repairs. It's a whole new ballgame in terms of safety protocols.
It really sounds like a major upskilling effort is needed across the board. Okay, moving on. Let's talk about the air inside buildings. Ventilation? Seems like that's getting more attention too.
You're spot on. Ventilation standards, especially those from ASHRA 62.1 for commercial, 62.2 for residential, are definitely getting more stringent.
How so?
Particularly in commercial buildings and multifamily housing, there's a much clearer push towards requiring measurable, verifiable airflow. You can't just rely on maybe opening a window sometimes or passive vents.
So calculations and hoping for the best isn't enough anymore.
Increasingly, no. You often need to prove the system is delivering the required amount of fresh air. We're also seeing more use of demand-controlled ventilation, DCV.
What's that?
Smart systems, basically. They use sensors, often CO2 sensors, to monitor occupancy or air quality in real time.
And adjust the ventilation.
Exactly. They ramp up the fresh air when CO2 levels rise, indicating more people, and dial it back when the space is empty or less occupied, saving energy. And yeah, the whole COVID-19 experience really put a spotlight on indoor air quality.
Right. Became less of a nice to have and more of a regulated necessity.
Precisely. It solidified the importance and the regulatory focus on making sure ventilation is effective.
Makes total sense. Okay, what about the building itself, the envelope, the push for overall energy efficiency there?
That continues strongly through the International Energy Conservation Code, the IECC. Jurisdictions are adopting the 2021 version, some even looking at 2024, and these bring tougher requirements.
Like what specifically?
Higher R values for insulation in walls, ceilings, foundations, big focus on air sealing, and particularly duct sealing is getting critical.
Meaning just taping the joints better.
More than that. Many places now mandate duct tightness testing, a blower door test for the ducts, essentially.
To actually measure the leakage.
Yes, and verify it meets a specific target, like maybe no more than 4 CFN cubic feet per minute of leakage per 100 square feet of conditioned floor area, tested at a certain pressure.
Right.
Slapping on tape and hoping isn't good enough if you have to pass that test.
How?
And we're also seeing smart thermostats becoming required more often in new homes, helps with more efficient temperature control.
It really feels like every single part of the system, from the equipment to the ducts to the controls, is under scrutiny for efficiency and performance.
That's a good way to put it.
Okay, one last big trend: electrification. We hear a lot about moving away from gas.
Yes, this is a major shift, though it's definitely more pronounced in certain regions right now. States like California, New York, Massachusetts, they're really leading the charge on decarbonization policies for buildings.
What kind of policies?
Things like mandates for all-electric new home construction. That effectively bans new natural gas hookups for things like furnaces or water heaters in those areas.
So no more gas furnaces in new builds in some places.
In some jurisdictions, yes. And consequently, there's a very strong push towards heat pumps as the go-to technology for both heating and cooling because they're electric and highly efficient.
Heat pumps are becoming the default.
In many new constructions in these leading regions, yes. We're also starting to see some areas implement actual carbon emission limits for buildings, maybe a total carbon budget per building or per square foot.
That's quite direct.
It is. And while these electrification mandates are geographically concentrated for now, the general trend seems clear. It's likely we'll see this push for electrification and heat pumps spread more widely over the coming years.
Okay, that's a lot of change happening all at once. It feels like a fundamental transformation for the HVAC world. So let's get practical. Part 3. What do professionals or even engaged homeowners need to do to stay ahead of all this?
Okay, number one, without a doubt, invest in knowledge. Continuous learning isn't optional anymore.
Training, basically.
Yes. Keep your certifications like NATE up to date. Make sure you're getting any required state CEUs, continuing education units, especially those focused on code updates, and crucially, given the refrigerant changes.
They too else.
Exactly. Prioritize training on handling R32 and other A2L refrigerants safely. Know the procedures, the tools, the risks. This is about safety and compliance, not just new tech.
Okay, training first. What's next?
Know your local codes. This is so important. National codes like the IMC or IECC are just the baseline.
Municipalities can change things.
They can, and they do. They might adopt an older version, a newer version, or add their own specific amendments on top. One town might use the 2018 IMC. The next town over could be on 2021 with local tweets.
You have to check every time.
Every single time. Verify the specific code version and any local amendments in effect for the exact place you're working.
Yeah.
Never assume it's the same as the last job.
Local knowledge is absolutely key. Got it. What else?
Collaboration. Work closely with engineers and, importantly, building inspectors. Don't wait until the end.
Get them involved early.
Yes. Talk early in the planning stages. Make sure everyone's aligned on the requirements. And be ready to provide documentation.
Like those duct leakage tests.
Exactly. Airflow readings, duct leakage reports, commissioning data proving compliance through documentation is becoming much more common, even required.
So, better communication, more paperwork potentially. Okay, final piece of advice.
Educate your clients. This is huge. Homeowners, building managers, they might not understand why you need to do certain things that maybe cost more or take longer because of code.
They just see the bill going up.
Right. So position yourself as the expert, the consultant. Explain the why. Explain the benefits of doing it right according to code.
Give me an example.
Okay. Say you need to do thorough duct sealing and testing. Explain to the homeowner, look, yes, this takes extra time, but the code requires it because leaky ducts waste a ton of energy. Getting this right means your system runs more efficiently, your energy bills will actually be lower, you'll be more comfortable, and we'll pass the inspection.
So, connecting the code requirement to tangible benefits for them: comfort, cost savings, safety.
Precisely. It justifies the work, builds trust, and shows your professionalism.
Those are really solid, actionable points. It's just so clear that staying informed, staying trained, and adapting is absolutely essential in HVAC today.
It really is. These building codes, they aren't just obstacles or red tape. They are actively steering the industry towards, well, a better future, safer, more efficient, healthier buildings.
So understanding them, adhering to them, it's not just about passing inspection.
No, it's about competence. It's about quality work. It's about future-proofing your skills and your business, frankly.
Viewing codes as guideposts, not roadblocks. I like that. Okay, on that note, here's something to think about. We've talked about a lot of changes driven by efficiency and refrigerant. How might the growing push for full electrification and decarbonization fundamentally change the types of systems we're installing and servicing even more drastically in the next, say, 5 to 10 years? beyond what we even covered today?
That's the big question, isn't it?
Definitely something to keep watching. Thanks for joining us for this deep dive.